Oh, hey, you guys, Mr. Frank. Hope you're doing well. Our last class before break. Uh, I'm recording this in my gear shed at my house. It's the quiet spot that I've found. Uh, yeah. So we're gonna run through the last part of achieving energy sustainability, chapter 13. Shouldn't take too long. Try to fill in the rest of those study guide questions. That'll be kind of what's due for today, along with a little vocab quiz. So um, let's go. And here, before we jump in, I'll just tell you this is kind of how I feel about this whole virus thing. that's that's my that's my goat. Okay. All right, let's see here. Let's see. Oh, I've got present. Okay. Um, so we're doing the survey of renewable energy types, and we covered lots of this last time. We got all the way here to modern carbon versus fossil carbon. Talked about that. Just quickly wanted to talk about carbon deposits again on planet Earth. We looked at this early on in the course. So here you can see, on our y-axis, we've got gigatons of carbon. And the atmosphere has a reservoir of carbon. It's one of the smaller reservoirs, but we're adding carbon to that through burning fossil fuels. So that's what we're talking about when we look at climate change. The ocean is also absorbing. Global oceans are absorbing some of that carbon every year. Our plants on planet Earth, of course, have carbon. Soil, we talked about that during our soil examination, soil chapters. Big carbon reserves, lots of potential for sequestering atmospheric carbon in our soil. Then you've got a little graph there, a little bar that's orange with kind of a sliding scale. That's the emissions that will produce, carbon emissions, and that's related to the next bar, which is red there, which is our fossil fuels stored in the crust of planet Earth. And that's one of the largest carbon deposits, right, or reservoirs. So lots and lots of coal, oil, and gas. And then other carbon reserves are methane hydrates, which are stored in the crust as well, and then in the deep ocean. And that's a massive amount of methane, CH4, that potentially could be released into the atmosphere with warming conditions. And then finally, you've got carbon locked up in calcium carbonate rock, limestone rock, all throughout the Earth's crust. And that's a massive reservoir of carbon. So just looking at where carbon is and the idea that climate change is effectively releasing carbon into the atmosphere, increasing the concentration of carbon dioxide gas and also methane in the atmosphere, and also the global oceans. Okay. Just looking at, oil, we talked about this a little bit. What's sort of remaining. This particular projection saying 160 years of oil remaining. You'll see different estimates in different places. Okay, so we're going to move through all these renewables, and hydroelectric power is considered renewable resource, right? Because it's tied to the water cycle. Water's constantly moving around on planet Earth, so we've got large numbers of dams in this country. We've kind of explored that already. And it's electricity generated by the potential energy and kinetic energy of moving water, right? So we've got three different ways that hydroelectric power can be generated. We've looked at the first two already: run-of-the-river systems, water impoundment systems related to like large dams and reservoirs. And then we'll briefly look at tidal systems as well. So here's run of the river. Again, you're diverting water from a river and running it along a culvert or a channel high up on a ridge away from the water course, and then running that water rapidly downhill through something called a penstock, which is basically a large pipe, to where it hits a turbine and spins a generator and creates electric current. Okay. Water impoundment systems, basically a big dam. You've got gravitational potential energy of all this mass of water behind the dam. and an intake at some point where water at high pressure is forced through or fed through spinning a turbine, which is again connected to a generator and creates electric current, which goes out of the dam through these transmission lines. Okay. Here's just interesting. This is a dam in Northern California. This is one of the, this is actually an overflow mechanism. So at high conditions, the water will actually exit the reservoir rather than spill over the top of the dam. It'll exit the reservoir here, which is just one interesting dam design. Okay, tidal energy. So the idea, this is becoming more common. A lot of research has been done on harnessing the energy contained in tides. The transition from high to low tide or low to high tide involves the movement of lots of water. And so again, that movement can be harnessed by putting a turbine underwater and connecting that turbine to a generator. So there's a couple of different approaches there, but you can imagine, in particular places in the world, the Bay of Fundy in Canada, for example, on the border of Canada and the United States and Maine, tremendous variation between high and low tide. And so there's a lot of potential for creating electric current from putting turbines and generators in that environment. Okay, we're going to look at solar. Solar, there's a few different ways of generating electricity through solar power. Photovoltaic panels have been the thing that we were all sort of familiar with. Many people in Southern California have PV panels on their roofs. This is something homeowners can do to generate electricity right there on site at their homes. They're large-scale PV or photovoltaic installations around. And that's certainly a mechanism of generating electricity by capturing sunlight. It's very common. But one of the really exciting and new developments is with solar electricity is concentrated solar power. Basically, a large array of mirrors focusing sunlight on a central tower, and then some molten salts being pumped into that central location in the tower, and being heated by those mirrors to a very hot temperature, and then that being used again to generate steam, in a contained way. And that steam can be used to spin a turbine, which is connected to a generator. Okay, so just looking at global solar energy capacity. This is sort of what's installed up through 2015 in terms of gigawatts. So you can see here the trend is exponential, and that installed solar electricity generation is increasing rapidly. And this has to do with the fact that prices are dropping rapidly. The technology is expanding, increasing, and prices for installed solar have been plummeting. And it's actually it's getting competitive with fossil fuels, things like coal. And that's why we're seeing, a drop in demand for coal and an increase in installed solar. Okay, and we'll look at that in a little bit, kind of wrap up the chapter with that. So again, geothermal energy, very abundant, using heat that's, found in the crust of the earth to generate steam and again spin turbines and generators. Excuse me. So we have geothermal plants in the United States. Here's an example of one in Nevada. Lots of geothermal potential in the United States. Lots of potential for generating electricity with geothermal power, tapping heat that's in the Earth's crust. There's actually worldwide lots of potential for exploiting geothermal energy, and students that went to Iceland saw that firsthand. Iceland is in some ways a leader. Here's a plant in Iceland, geothermal power station, and Iceland gets roughly 25% of its electricity from geothermal power and does a lot of heating of homes and buildings with geothermal, with steam heat. So individuals can install a form of geothermal energy. It's it's called a ground source heat pump, so it's not the same. But effectively, what's happening with these, it's a heat exchanger where there's a heat differential, below the surface of the Earth. The crust is warmer generally in some places, certainly during the winter months, significantly warmer than the air temperature and then the surface. So you can have this set up installed. In some places, it can be a very cost-effective way of providing heat for the house, and then alternately, possibly cooling during the hot part of the summer. Okay, wind energy, another renewable energy supply, can't be depleted. There's constantly differential heating of the earth, and air masses moving to try to even out that heat, disparity. And so, using a wind turbine, converting kinetic energy of the wind into electrical energy, basically spinning a turbine with these large blades attached, and that turbine being connected to an electric generator. So again, exponential growth in cumulative total capacity installed wind energy on planet Earth. Small fraction of the total amount of energy that we use, but it is increasing rapidly. Okay, Germany has been a leader in wind power installation, but many countries are rapidly jumping on board. And something that I stuck in here that I think is fascinating is this idea. I think we've mentioned it before in class. This idea of biomimicry. Looking at nature closely and realizing that we can gain, make rapid gains, tremendous gains in efficiency by creating, our models in our built environment in a way that mimics nature. So this is an example, a wind turbine that is modeled on a humpback whale fluke, and the tubercles that are part of the whale's biology can be incorporated into this turbine blade design and actually make the blade significantly more efficient at generating electricity. So that's bio-inspired design or biomimicry, and that's a growing field in environmental science that combines, studying nature and efficiency of our built environment. Okay, jumping over, just covering kind of randomly here this idea of the hydrogen fuel cell. It's basically using a battery where almost, in some cases, water is part of the source to generate the hydrogen. It's one possible approach to generating fuel for automobiles. Certainly, Tesla is leading the charge with non-hydrogen fuel cell approach, just electric batteries. So, but this is a quick schematic just showing that you've got hydrolysis happening here in the creation of electric current through burning of hydrogen. Okay, again, going back to Tesla, the Powerwall is a really interesting development in the last couple of years. This idea of battery storage for electricity generation right on site. It's allowing lots and lots of homeowners to get in and have PV panels installed on their homes and storing some of that electric current on site for use when the sun goes down or during cloudy days. Okay, so we're almost at the end here. So what's happening globally with this move to renewable energies? There's a global movement to divest money from the fossil fuel industry, from coal, oil, and natural gas, to pull the investments away from those companies and to target banks that are investing in those, and actually redirect those funds to renewable energy. And we know that that is the future. We need to transition away from fossil fuels. Carbon-intensive fuels are loading up the atmosphere with carbon dioxide, and we simply have to move away from those to avert the worst effects of climate change. So, just a few headlines here looking at divestment, pulled these down just so you can see it's something that's underway. Lots of colleges and universities are moving away, taking their money out of fossil fuel investments and redirecting that toward renewables. And as that happens, it's lowering the cost for things like solar power, wind power, making them cost competitive with fossil fuels. Okay, so we're again seeing more installations of solar power. Solar power is ramping up. And you can see here that the cost, the yellow line is dropping radically, and the blue bars, solar PV installations, are increasing exponentially. And that's the story you'll see, undoubtedly play out globally, in the next 10 years and beyond, that renewables become less and less expensive, begin to take more and more of a market share. And that's, part of the work that we're doing at Campbell Hall to be ultimately a carbon neutral educational institution. So nevertheless, and this is sort of the last part, is that power use globally is projected to increase, and you can see that the United States is part of the OECD Organization for Economic Cooperation and Development. We're one of those countries, and many countries in Europe are part of that. And so our energy growth is projected not to grow dramatically, but instead the largest growth area for energy usage in the developing world is occurring in Asia up until 2050. And this is, I think, the final slide here. You can just see that renewables, the graph here for renewables, a projection through 2020 into 2050, renewables are going to take a larger and larger share of the total portfolio. And of course, you can see in this particular one, renewable petroleum and other liquids are still increasing, and certainly the idea is that those have to diminish or drop. Oh, I lied. Okay, the final thing then, this is it for reals. Hawaii is just working rapidly toward transitioning away from fossil fuels, partly because of their geography and the unique conditions that Hawaii has, relatively sunny place, and also a windy place. So about 30% of its total generating capacity is either solar or wind. And that's an exciting development, and a place that the rest of us need to join. So, okay, so that's it. Want to say thank you, for hanging in there. I know this is a difficult environment to learn in, but you guys have been doing a great job. Turn in those questions, the answers to those questions. You may have to look up one or two from the reading or do a little bit of research on your own. But I'm here to support you with office hours, and feel free to email over the break. I'm going to be around. So, okay. I miss you guys. Take care.